Hey everybody, I'm Michael Hall.
And I'm Robert Wolf, and welcome to Innovation Coffee, where the coffee's hot and the innovation's hotter. Not sure if you heard that, but yeah. So this is another episode of Innovation Coffee brought to you by ARM. We look forward to bringing you the latest and greatest developments happening in and around the ARM developer ecosystem. Of course, during these broadcasts, we love to bring on featured guests to talk to us about all the cool stuff that they're developing or working on ARM. So this episode, we have a interview with Beau Paisley. We're going to be talking about Linaro Forge, which is a very great product and service, and we'll be getting in or diving into that shortly. But first off, I would like to first mention that Innovation Coffee, while we have been for the last, I want to say maybe 2 years now, going live every week, we will be making a transition to bi-weekly episodes. So that means that starting next week or starting this week, we will only be coming to you once every other week. Next week will be our first week off in a very long time. So, we'll be sure to set reminders. We'll make sure we make a nice little Twitter post or something about it. But we do look forward to, spending more time making these episodes a little more robust. It'll allow us to kind of keep the guests flowing and the content flowing for you all in this regard. Mike, but did I miss anything there?
Just to say that we're taking we're cutting back how many episodes of Innovation Coffee we're doing, but we're doing more video content as well, right? Like you and Gabe have been putting out some new content. I know I'm on the hook to produce some more stuff, so it's not like we're cutting back on the amount of video content we're producing. We're just switching it up a bit, so there's going to be a little bit more variety in terms of style, content, runtime, that kind of thing. So you will be still seeing a lot of us, our faces on video, just not always Innovation Coffee every week.
Yeah, we can't let you forget about us, and we'll let you get sick of us in other ways. One of the cool things is that while we do these live streams, and we have been doing these live streams every week, just like Mike said, we have this other content coming out. I think we've mentioned it before, but Gabe has started launching what we call the Weekly Dose on ARM series. He publishes one of these videos every single week, and the YouTube channel, you can go check those out. This kind of summarizes everything that happened in the previous week, so you can go check that out. We also are going to be starting a new series called the How Do I on ARM. This is a technical series that includes, or will most likely include, a learning path, some other complementary material, and of course a video that breaks down a question that someone has online or something that we would like to showcase from a technical standpoint. And then we have a new series as well called Did You Know? And this is stuff that maybe you just didn't know about that's happening on ARM. And these are little shorts that we'll be posting on YouTube as well to kind of get you up to speed on the many things that are going on, in this ecosystem and in the developer communities, especially in the stuff going on with our partners. Michael, do we want to go through the last week's episode real quick, give a kind of brief overview?
I certainly do, yeah, because we had my good friend George Castro on talking about Linux desktops, and like a topic that's been near and dear to my heart for a long time, since when I first met George, both of us working at Canonical on Ubuntu. So it was really nice to hang out with him again for this show. Really cool to see what he's working on. Some really, really interesting approaches that he's taken to his project Bluefin. So yeah, check that out. If you're a Linux desktop user, that's something that you're going to find interesting.
Yeah, we'll be sure to share the link from last week's episode in the chat right now in just a minute. So on top of that, if you do enjoy what you're watching right now, make sure you smash that like button, and don't forget to subscribe to the YouTube channel, because we do these very often. As we also mentioned, a lot of other content gets published on our YouTube channel. If you aren't already on our Discord server, make sure you head on over to https://discord.gg/ARM software dev. That is our Discord server. We love to have you there. And we look forward to, keeping in touch with you over the week. We're there. Us evangelists are kind of hanging out there all day. There's over 200 experts from within ARM there to kind of chat with you, go over any sort of questions you may have. We also have a forum there that you can ask questions we can get to there as well. So, feel free to go check that out.
We also do 3 office hours every week in different time zones. So we've got one for Europe and Africa. We've got one that covers the American time zones, and we just recently started one that covers the APAC time zones as well. So those all happen in Discord in one of our voice channels there, so you can come talk to us live, show off your projects, or get support from us, whichever you want to do.
So like I said, you'll get sick of us in all other ways. All right, cool. Like, I think it's time. Let's bring on our guest,
Yes.
Beau Paisley from Linaro. Hello, Beau. How are you doing today?
Good, thank you. And yourself?
Great, thank you so much. Yeah, I'm glad to have you here on Innovation Coffee. I think the topic at hand today is Linaro Forge, and we will be diving into that in just a moment. But I really do think it's important for anyone watching either live or on demand later to get to know you, Beau, and who you are, what you do. So if you could maybe answer those questions and tell us what you got going on at Linaro, and just a little bit, maybe a personal anecdote if you'd like to share.
Yeah, sure. So most of my career has been in technical computing. My background training was in applied mathematics, and a lot of my career working in particularly climate weather, things like the WRF code you guys might be familiar with, in those kind of sciences. And then maybe 10, 12 years ago, I got involved with the Forge project in a little bit more of a customer-facing role. I'm a solutions architect, so I support the sales guys and the marketing guys of connecting with our customers and prospects.
That is awesome. Beau, pleasure to meet you, and thank you so much for joining us. So we have a series of questions for you, and I think that before we dive into Linaro Forge, because that is the topic at hand, I thought it might be better to know what Linaro is first. So you work for Linaro, and people can go visit linaro.org to kind of go get a deeper dive into what Linaro does. But from your perspective, or maybe you can give us a little lowdown. What is Linaro?
Yeah, so Linaro is ostensibly a nonprofit company to support the ARM ecosystem. Some years back, I think it's probably 5 to 10, everybody that was building on ARM, the likes of Google and Azure, Qualcomm, pretty much everyone in the system was in a mode of they were all kind of doing the same work. It wasn't very efficient. It wasn't their core business idea. So they all got together and formed Linaro as kind of a community to support the open source software for all of these large participants. So people join Linaro as kind of a member, a supporting member, and have access to the Linaro ARM architecture experts and the open source software that they support. So a much more efficient model of supporting ARM in the ecosystem. So that's kind of what Linaro's main thrust has been for a long time, to provide consulting, helping either members or folks that want to just come to Linaro for consulting on ARM architecture. So Forge is relatively new to the Linaro team. I think it's about 8 or 9 months, maybe 10 months now that we've been part of Linaro. And we started about 15 years ago as a fairly small startup company focused on HPC development tools, particularly debugging and performance engineering related tools, and got a lot of growth in that and became very much a leader in the top 500. Most folks in the top 500 that are doing HPC have been using our tools for 7 or 8 years. And our evolution went from the startup to ARM. So ARM purchased our company, and we were part of the ARM team for quite a while. I think about 7 years, 8 years maybe. And this was in the phase when ARM was moving more into the server market, and obviously HPC is kind of a server class thing. And ARM's not just about HPC; it's a lot of different server class stuff now, and very competitive in that. But when we were started, we were part of the strategy to help ARM get into that, particularly in HPC. And we work on Graviton systems. We work on Fujitsu system. It's #1 supercomputer in the top 500 for ages. So very large scale stuff that ARM is doing. And we were part of that growth. It kind of came to a stage where ARM's a little more focused on IP and hardware and those type of things, and supporting a big software team wasn't core strategy of what ARM does, and it wasn't really serving ARM anymore, and it wasn't serving the growth of our products. And so they found a new home for us at Linaro. So now we're part of Linaro's team. A little bit different than the core stuff at Linaro in that we're a commercial product. We sell licenses. It's not open source, and it's a for-profit venture. We sell licenses with the goal of making revenue to support the team. So that's kind of the evolution and where our team is now. It's really been fun. Of the core team, we've all been together for over 10 years, like the engineers, sales, marketing, everything. It was about 15 of us. And we've all been with the project for a long time and kind of view it as our own little company within other companies. And we're all at Linaro now.
Oh, very nice.
So, Beau, you mentioned a couple of terms, and I just want to get a definition for them for our audience. You mentioned HPC and also performance engineering. Can you give us kind of a high level what those two things are?
Yeah, absolutely. That's a good point. So HPC, high performance computing. So this is a type of computing that gangs together lots of server class machines on very sophisticated high performance networks, massive machines, tens of thousands of nodes. So imagine tens of thousands of desktop computers ganging up together to solve a single problem. And they're typically problems, things like in climate weather, that's kind of my background, but used a lot in fluid dynamics, computational fluid dynamics, genomics. HPC had a big role in the research in finding a cure for COVID. So very large scale computation in search for a cure for that, which is a lot of fun and excitement. We had a lot of clients that, given the urgency, they were given top priority, where if you were doing something that was supporting that effort, you had first in turn on a supercomputer. And so these are machines that cost tens of thousands, if not hundreds of thousands of dollars an hour to run. And a lot of scientists were getting top billing on that. So HPC is really kind of this concept of really big machines on fancy networks solving large technical computing science type of problems. So in performance engineering, is really the process and set of methodology for getting the best throughput, the best performance out of your codes and your machine. So as I mentioned, these machines are very expensive. So you can imagine that the scientists that get X hours of time to run their problem on this machine want the code to run as efficiently as possible and to use the machine as well as possible. And it's a big challenge because the folks that are doing the computing are typically scientists. They're chemists, physicists, biologists that might not be traditional compute people. And so it's really a team effort of applied math and machine level people working with scientists to get the code running as fast as possible and using the machine in the most efficient way possible. So performance engineering is just kind of the process of doing that, of applying the methodology of looking at problems and using tools to get the performance out of what you have.
Did that answer your question, Mike?
Yes, it did.
Nice.
If anyone has any other questions or has a follow-up question on that, though, put it in the comments here in the YouTube video, and we'll bring them up. Absolutely.
So Beau, I went to LinaroForge.com. By the way, that's the website if you want to go learn more about Linaro Forge, LinaroForge.com, and found that there were several words or acronyms that I then dug myself into a rabbit hole on. Right, as a developer myself, I look at an acronym and I'm like, okay, maybe I can go learn about this particular thing. This acronym might be some technology in itself. And so these two acronyms that I kind of have a question about or maybe there aren't acronyms at all, but what is Linaro DDT and Linaro Map? So, when you go to LinaroForge.com, it basically says that Linaro Forge combines Linaro DDT, the leading debugger, and there's also mentions of Linaro Map in there, available as standalone products. So maybe you can kind of walk us through what is Linaro Map, what is Linaro DDT, and how does this relate to Linaro Forge?
Yeah, good question. So Linaro DDT is our debugger, and this is a debugger focused on large-scale HPC type of code. So codes that use multiple processes and multiple threads, typically using OpenMP for threading. And the debugger was designed from the ground up to really be focused on those type of codes. So both the architecture and the user interface is really optimized for people that are running codes where you might be using thousands or tens of thousands of processes with many threads within each process. And those processes might be using GPUs, NVIDIA, AMD, and even Intel at this point. So it's really focused on that type of coding. Now, in terms of what it stands for, it's been kind of a fun internal joke over the years. And when I started, coming from a U.S. market where I have a background in climate science and read Rachel Carson when I was a kid, things I was like, my goodness, DDT, that's not a friendly term in the U.S. What does it stand for? And never really kind of nailed that down. I think the founders just like used the term, so it doesn't actually stand for anything, but that's the name of the product. And like a lot of products that became a brand with a lot of momentum, that's what we've been using for a long time. So MAP is our source code profiler. So this is a tool that enables you to profile at a source code level and then bring up your application and see where time is being spent, kind of a hotspot. Imagine if you're familiar with gprof, it's kind of a concept like that, but it's extended, once again, for an HPC focus where you can see how time is being spent across all your processes, how it's being spent on different nodes, how time breaks down in given threads, and really isolate it to sections in the code of where that's going on. So very easy to use. We're very focused on kind of the science user. As I mentioned in HPC, there's a challenge in that the actual people that are getting the results, the folks that are quote doing the work, they're scientists that aren't always computer science or technical computation type of folks that aren't tools experts. And our focus was to give a profiler where the end scientist, without a lot of learning and without a lot of effort, you don't have to instrument your code. It's a sampling profiler. They can go in and get some really useful information and hopefully improve their configuration or improve the source code, or if necessary, go to an expert. Most of these big sites have dedicated computational scientists that are experts in really powerful tools. But our goal was to enable them to find their spots. So that's at a source code level. And part of that is a tool we call performance reports. This is more of an application profiler where you don't need symbols. You just run your typical release build and you get a one-page summary of how time is being spent. So at a very high level, you can see how much time is being spent in compute, how much time is being spent on a GPU, how much time in MPI, IO, and a little bit of breakdown. So a very quick way to see is the application behaving well and give you some focus of where it might not be right or maybe tuning. So in terms of performance engineering, a more common need lately than actually going in the old days, you think of optimizing the code, it means going in, changing lines of code and rebuilding, especially as we have a lot of architectures, as ARM has grown in the ecosystem, really different architecture, and a lot of the optimization is not always going in and changing lines of code. I mean, that does happen, but a lot of times it's just reconfiguring the code to run a little bit different way. And so having this application level profiler to see, is it configured well and how's the performance going? So that's kind of our set of our tools. Forge is just the umbrella that bundles those all together. We typically sell them as a integrated toolkit together, but customers certainly can purchase licenses for each one separately.
Very, very nice.
So, Beau, you mentioned you've got a debugger for source code. You've got a profiler for source code. What languages do you support with these tools? Like what programming languages? Yeah,
so that's a great question. So first and foremost, the quote traditional languages of HPC, Fortran, C, C++, and most fairly modern versions of those. We're fairly up with the standards on all three of the traditional HPC compiled languages. One that we've entered into recently over the course of the last few years is supporting Python. So we're seeing a lot of people starting to use Python for real HPC. We we have a customer with the government that's using Python running on several thousand nodes for a large-scale model. And a lot of the large labs are ramping up on that. The DOE labs, especially at NERSC, several of the folks in New Mexico that do that kind of work are using more Python because it's quick to bring up. And it's, for all reasons that Python is easier, it's becoming more popular. So also Python. Another one I'd like to mention on Python, and I've been really excited about this, is we started going to the Python user group meeting for technical Python computing about 5 years ago. And the keynote speaker was a professor in history. And so not somebody that you would traditionally classify as a computational oriented person, but he had hypotheses about some history analysis that required a lot of compute. And with a little bit of hand holding, but not somebody doing all the work, he used Python notebooks and MPI for Pi and solved this large scale technical problem using Python, which traditionally wouldn't have happened. He would have had to farm that out and get a hardcore math computer science person to do it. So I think Python's really exciting that there's a lot of people coming to HPC and taking advantage of HPC who traditionally couldn't, which obviously when it's a fan of the sciences, that's great progress. And it means a growing market for HPC. In all fairness, HPC is growing, but it's not nonlinear like machine learning and things like that. So Python opening that up to other areas, I think is really exciting. And we've pretty much rounded that out. We're starting to look at other languages that might be used in that. But in all fairness, I think most non-compiled language stuff at this point is in Python. We see some in R and Julia that is growing, and we're looking at that, but that's where we are now.
Nice.
So far, we've gone over what is Linaro, the company that basically has Linaro Forge in their portfolio. We've talked about Linaro Map, Linaro DDT, two tools that are folded into the umbrella that is Linaro Forge, and we talked about some of the languages that are supported. I have a couple questions here from our viewers, which I want to go into real quick. And then kind of after these questions from our viewers, I'd love to kind of start talking about some of the features that are available to anyone using Linaro Forge. So question number one comes from JM on YouTube, asks, one of the projects I have on my desk is related to ML and is a home video pet tracker. Would this be considered one of those HPC related products or projects? Not sure if you're able to answer this one with that much information, but maybe you can give it a shot.
I can give an overview. So the way that ML is done requires a lot of compute, but it's done in a very different way than traditional HPC. Traditional HPC has a single process that divides up a great big problem. The one that's close to me is weather climate. So for example, if you run a supercomputer on a weather climate mode, what you do is you break up the map of the world or whatever you're modeling into little squares. And there's one process that works on each one of those little squares. So for example, our morning weather in the United States is on a 1 kilometer grid. So for each square kilometer, there's a process that's doing the work for that little square and communicating with the squares around them. But everybody is doing the same stuff. It's the same code, the same physics, and then they all communicate together. Our tools are very optimized for that type of large compute, traditional, it's called single process, multiple data HPC. ML is very different structure. It uses threading within the architecture on individual nodes, and they farm out parts of the neural network onto different nodes. So it's an extremely different architecture. So to answer your question, at this point, we're in the mode of seeing how our tools can help in ML. In all fairness, we're really not optimal in that because of the different architecture. The one area that I think we do give valuable data is at the application level. So I mentioned performance reports will give you a single page at an application level of how things are going well or not well. So for ML, if you're using a multi-node thing, that can at least give you a starting point of like, maybe there's something wrong. So if you see a ton of IO or a ton of communication going on, it'll at least flag, hey, there's might be an opportunity to improve things here. At this point, I don't say we're a complete robust solution in that area. Obviously, it's a growing market, and also a lot of people that do HPC are also doing ML. So I came from NCAR, and I'm close with that community, and talking to my buddies there. Their new machine is GPU oriented, and it's probably going to spend more cycles doing ML than actual climate SPMD models, which I find really interesting. Of those two technologies are becoming much more tightly coupled, and it's a similar market. So obviously it's an area we're looking into. At this point, to answer the question, I don't think we're a complete solution in that area.
Yeah, and I mean, like, people also have to consider the cost, right? Like, is this a project you're just doing at home, or is this a project that might turn into a product that could, require this type of?
How much are you willing to spend on your pet tracker at home? Is it $1,000 an hour? Probably not.
Yeah. So we have another question here, and then Michael, I think, has some stuff he wanted to add to this. So this one comes from Pipilaya, also from YouTube. He says, nowadays, HPC is being deployed in the automotive world. How can Linaro be useful in automotive?
Yeah, so we've had customers in automotive for a long time. The bulk of our involvement in automotive is related to computational fluid dynamics. And in automotive, there's several different aspects. And it's interesting that we have customers that build computational fluid dynamics codes for the body. Air goes around the body of a car. Obviously, we've all probably seen pictures of like the flow of stuff around the body of a vehicle. That's a whole science in itself. And there's experts that do that. And we have customers that have codes that do that. The engine, modeling the internals of an engine. And there's a whole broad range of that. And we have multiple customers that have codes that do CFD to support that part of the model. As we're starting to see EV, there's emerging aspects of how that type of energy is modeled. Very novel stuff. A lot of that's being done in kind of the open foam world, where it's got open source stuff. So that's an area that's been bread and butter for us a long time, mainly in fluid dynamics. I know there's some other areas.
Is it like, what about like software defined driving, like software defined driving? Is that like a thing that HPC would be useful for? Is Linaro Forge something that?
Not exactly. So once again, that is so fluid dynamics, much like weather, is you break up a domain into little parts, and there's a code that solves those little parts. The automated driving is all of the different parts, and there's a growing number of them in an automobile, do different things. They all have different tasks that they've been programmed to do in this big system. That's not traditional HPC. It's certainly large compute, very large compute. Yeah. But it's not a data decomposition type problem like traditional HPC.
Gotcha. Thank you.
You kind of gave an overview of what workloads are good, or like what workloads benefit from HPC, which kind of leads into my question, and maybe you answered it a little bit already, but what kinds of workloads will benefit from Linaro Forge specifically?
So the very sweet spot are the type of loads where conceptually it's a data decomposition, and hence kind of this term single process, multiple domain, is you have a whole bunch of data on a large type of domain that you break down and solve in little pieces. And fortunately, a lot of sciences can be done that way. Fluid dynamics and weather, which I am background in, of like you just break up segments. So imagine on a car, you have tens of thousands of nodes to work on. You might have one little process that's modeling the area around the mirror, and all the compute is there. And you have another process that's modeling around the bumper, something like that. You're just decomposing the data and putting it onto different processes. That's kind of the traditional HPC. That's the sweet spot of what we do well. A lot of chemistry, biology problems, life science problems can be decomposed at a data level, where each little part of the data set, it can have a process with some threads or whatever, but conceptually it's doing the same math and physics and using a separate process to do it. So that's kind of the sweet spot of traditional HPC. That's the sweet spot of what our tools do well. Now we definitely we work in areas where there's types of problems where, there's one set of processes that do A task, there's another set of processes that do B task. And our tools certainly work of being able to do that and debug in particular into the different subdomains of the problem. But kind of the core of it is kind of this data decomposition type of problem that you see in a lot of the quote big sciences.
Okay. So for automotive, maybe not for a specific, like for one car, but maybe like modeling all the traffic in a city, it would be good for.
Yeah, very much so. And it's interesting, that is a growing domain, and I've connected with a lot of people of it, and that's a problem that can be very much broken down on a grid. Just imagine the grid of a city as you would break it down to run a weather model across it, and looking at traffic in a modeling sense, very much so. And that's actually an emergent. That's interesting you say that, because that's one relatively new to me, and over the last few years I've encountered more clients doing that exact type of thing, as traffic obviously keeps getting worse.
Yeah. I wonder if in the future, like one of these smart connected cities, the timing on all the traffic lights would be, computed live to reduce traffic jams and, increase just general throughput through the city.
Yeah, I think it is. I think they're working on that. And part of the problem I think is still kind of on the bleeding edge is cars, self-driving cars. If you tie that all together and provides the information for the driving systems to optimize the route, which we as humans would not always do best, is, that's a possible future.
Awesome. Yeah. So I love this so far. I want to kind of take the developer lens on now. I want to put the developer lens on. I am a developer, either, on my own, a contractor, or working for a big company. And I am watching this episode and I say, okay, I like this. I want to go experience Linaro Forge. What is the developer journey? What does that look like for me right now? I just watched this YouTube video, and I'm going to go to linaroforge.com, and I'm going to go contact Beau, or I'm going to go download this thing, and then I'm going to put this on my computer, or how does it work? What's the developer journey look like as soon as they leave this live stream?
No, that's a great question. And we're very much, the nature of the product is very consultative selling. So it's not something that you just download and head off on your own and never talk to us. That's not the best experience. We have a trial. And I suggest, if you want to try it out, the best practice is get a hold of the trial. To be most efficient at it is to connect with me and our sales team, and let's schedule a demo and talk about your needs, and set up how to show you how to best use the product. Because I think, typically in 40 or 50 minutes, I can go through, hear what a prospect's interests are, and show you some things that'll get you on the path to success much quicker than just, installing it and poking around. But that's certainly an option. Certainly, people like to be self-tinkering and, download the trial. So yeah, the trial's on our webpage. And you can try that. I forget what the parameters are. There's a time limit on it and a size limit, and all that's adjustable depending on your needs. But I suggest if it looks like it would help you, is reach out to us and let's talk about what we can do to understand your needs and show you what it does.
Very cool. Yes. I mean, I'm going to pull this up here real quick just so that people can kind of see. If you're, not able to go check out the website right now on your own, we'll bring this in. This is the Linaro Forge website. I'm going to just make it right here, fit the screen. Top down, just like Beau was saying, you can go over here, get a free trial of it, contact them. He highly recommends contacting them, reaching out and checking that out. Kind of going down this list, it looks like all the questions that we've asked could be answered right through the website, right? So, what is Linaro DDT? What is Linaro Map? Linaro Performance Reports? Beau, did these get added to the website after we met? Because I don't think I remember seeing these here when I came last time, but maybe they were, and I didn't notice them.
I think it has a little bit. It has. It's which is exciting because this is an update since I last looked at it also. And part of the just kind of on the business side of our discussion, just did want to highlight, I don't think I said much to it, is when Linaro purchased our team, they're very excited to grow the business. They're very excited to take on more customers and make money, whereas we served a different purpose at ARM, so the goals were a little different. So in the last 8-10 months, there's been a lot of work around the board. We have a new product marketing person who's really fired up of trying to improve the web page and improve the communication and all that type of stuff. So it's quite likely there's been improvements since either you or I looked at this.
Very nice. Did you want to go through any of these features? I know I kind of asked a question, but I think we glossed over it a little bit. We have the cross-platform, fast debugging, low overhead profiling, short learning curve, wide issue coverage, and single and multi-threaded profiling. Are there any of these features you think that get asked about more than others when you meet with clients?
So one I'm not sure we touched on is important is memory debugging, which in HPC, and if you've ever written code, you've had problems where, you overwrite an array or something like that, or you fail to free memory, that type of stuff. And in HPC, with a large number of processes, that problem just gets exponential. And that's another one of the things that we've done in a quote HPC way is helping find memory problems at very large scale, everything around that. Once again, the best way to actually show that is let's, here are your needs, and I can kind of show you that to you in detail. The text doesn't quite do it justice as demoing it. The one other one I wanted to highlight, and I think this is really important, is we are not part of ARM anymore. And even when we were part of ARM, is our customers even would ask us, hey, are you going to continue to support x86? And when it was a thing, are you going to continue to support Power? We're very platform agnostic. We support x86. Obviously, that's still the majority of our customers are on x86. Intel and AMD is growing. AMD is obviously very big in the markets. So we're not just on ARM architecture, most major systems. In fact, we literally just deprecated Power in the last few months. We have a few large labs that were big Power users for a while, and that was a first-class citizen as long as it was a thing. And GPUs, CUDA has been around for a long time. AMD's been rolling out a few sites now, and we're just about wrapped up with Intel support for the new DOE machine at Argonne. So I just wanted to highlight that because a lot of people, especially when we were at ARM, were like, all right, are you just ARM now? And Linaro is largely about ARM, as you know, also. And so just wanted to highlight we are not just ARM, we're cross-platform.
What are some of the differentiators there? So the question I have, I guess in particular, is do developers experience any benefits and/or are there any differentiators when choosing an architecture? Is it easier if they were working on ARM? Is it easier if they were working on x86? What if someone was working on x86 and wanted to transition to ARM? What does that look like in terms of benefits or the experience dependent on the architecture? Is there any differentiator?
No, that's a good point to highlight. In fact, at SC last year, one thing that customers brought up to us more than we thought to solicit of them was one of the things they liked about our tools is going between architectures, be it x86 to ARM or from CUDA to an AMD GPU, is our tools just look and feel the same in terms of how the tools operate on different architectures. It all feels the same. So if you're an expert at our tools on x86 and you want to start using them on ARM, it's a really easy process. Now, kind of want to caveat that because I've been learning myself of they're very different machines. The AMD GPU is very different than CUDA, and ARM architecture 64 is very different than x86. So what you see looks different. And for example, when you're profiling, the things that you see and how you have to understand them, the expertise for it is that in itself is, but the tools are all portable. So in terms of using them, that part of the journey is really easy.
So as the world goes more and more increasingly towards ARM, Linaro Forge works there too. Yeah, and that's yeah. So as you transition all your stuff over from x86 to ARM, you can still use Linaro Forge. Don't worry about it.
Absolutely. In fact, it's essential. So we talked about performance engineering is, in the old days when it was just a new generation of x86, I wouldn't say it was free, but going from one generation of x86 to a next, and we're not going to start the KNL discussion or we won't finish, but excluding that, going from one generation to another was relatively simple in terms of performance portability. They changed vector sizes, but a lot of that was hidden for you in the libraries. And I've been through that many times myself, and it was fairly simple. And ARM is also fairly simple of amazing how many big codes just out of the box compiled, ran, passed the correctness tests, right from the get-go on early ARM architecture systems. Now, getting the last mile of performance, sometimes that'll take a little work, but even that has been fairly easy. But our tools will make that very simple to, and it's not just getting it done. One thing I'd like to highlight is an important part of profiling is not with the goal of where can I make changes in the code to improve it. It's kind of a regression test of like, am I getting the level of performance I expect on this code? And a lot of the times going onto an ARM system, it's just been happening. Now, obviously, it's not always free. Sometimes there is some work.
Very nice.
So I'm glad you brought this up because my next question is about that kind of optimizations. We've had a lot of guests on the past year talking about using like the new intrinsics that have been added to ARM CPUs, the SIMD instructions, or like accelerators like our Ethos NPUs or GPUs even, like you've already been talking about. Is that something that Linaro Forge can help people do to get their code running even faster on these kinds of HPC environments? Is that a thing that is common in HPC environments even? I know you mentioned CUDA, but are there any others that are out there, and can you take advantage of those?
Yeah, absolutely. In fact, one of the features in our most recent release of MAP was a table that helps you break down time spent in libraries and the sub-functions of libraries in different permutations, because that's exactly a big part of performance engineering is not just changing lines of code. In the old days, it was like, oh, changing lines of code to make it. Now, a big part of it, especially in HPC, is swapping out different libraries or pieces or runtimes, whatever you will, to see how that affects the code and be able to see it at that level. For example, in the HPC world, there's these libraries that provide the basic linear algebra and differential equations, which are bread and butter in technical computing. And most vendors provide their own. So Intel has their own, AMD has their own, NVIDIA has their own. And a lot of times there's the exercise of, okay, I configured the library like this, and I'm going to use the Intel one. How does it look? Or I'm going to use the OpenBLAS standard, and I'm going to compile it like this. And a lot of iterations of trying the different frameworks and libraries in different configurations and builds, and seeing how it affects it. Or even the big kind of exercise of like, okay, is the nature of my code, can the computation be done better on a GPU? Swap out a GPU library for a part of the computation to be able to quickly see how that affects overall performance. Is becoming a larger percentage of the work, so to speak, in a performance engineering exercise.
So how does I guess this is a two-part question, right? Because Linaro Forge, people who want to use Linaro Forge are recommended to kind of go consult with you, right? So how does this work in terms of consultancy, especially, I guess, like in terms of Linaro's HPC expertise? Do you have experts on hand there to help people with their HPC Linaro Forge experience? So like, what does a Linaro consultancy look like in terms of this? Number one. And then number two is for people who are going to go try Linaro Forge, let's just say they do opt in for some consultancy. What does this free trial look like to them, right? So they want to get consulted by you, but then they're also now, downloading that free trial and getting ready to go experience Linaro Forge for the first time. So like, what does the free trial include, and what does Linaro consultancy look like?
Yeah, that's great. There's a couple phases. So the first phase where you're a prospect, so to speak, you don't have a license, but you're making the journey to see, is this product going to help me? That's largely, I'm involved with that. And that involvement is usually like showing the product and how it works and trying to come to a stage of like, is this going to help you? And if so, like get set up with the trial on your own codes. And not always, but I will often go down the steps of like, all right, you're trying it on your code. What is going well? What's not going well? How can I help you solve that? Usually that's kind of limited to a level of solving it on your given code. And we get a solution. Hopefully that means someone's interested in having a license. One thing we're ramping up in the Linaro world, at ARM, we weren't able to do much of this, but we're really excited to do more of this. Yeah, we have a lot of internal HPC expertise and some ARM architecture expertise and x86. So we have a lot of x86 and ARM architecture expertise. And so one thing we've been ramping up is like, all right, you've got the products in hand, you're using them, you're profiling your codes, but you need more help. You need some in-depth help of like, how can, it looks like there's an opportunity for more performance, but you need some help, is connecting with us on a consulting basis to do that. Classic one being, and we have a lot of customers that pretty much their whole history is x86. They literally have, that's pretty much it. They've only worked on one architecture, and they're moving to ARM, and things are going pretty well, but there might be an opportunity for even more performance, and coming to us and getting some, real hands-on, in-depth, let's go over your code together and go through and make some suggestions of how we can improve it. So a couple phases. There's kind of like what we'd call the traditional pre-sales, and that's kind of me, of like helping folks with their problem and seeing if the product is going to help them out and make a decision if it's something they want. And then the kind of post-sales, in-depth, actual consulting time, if they need that, to really dig in, especially in performance. Debugging, we certainly do that. Usually that's more of a support level thing, but performance can be a little bit deeper.
All right. Well, so Beau, I think we're getting to the top of the hour now. This is pretty much when we start to wrap things up. I know that I guess the last question here is like, if someone did want to reach out to you, if someone wanted to consult with you, I know, going to LinaroForge.com, there are ways to get there. Is that the recommended way to get a hold of you? The contact us today button? Look, I'm clicking it. Let's see what it does. All right. There's a little kind of form to fill out.
That's the best. So that'll go to me and the sales team. And we're kind of the first line to see how we can help you.
Okay, perfect. So this is the recommended way. Perfect. All right. So, Beau, last but not least, this is kind of a shameless plug opportunity. Do you have anything you would like to plug for us? I mean, is it, other than sending people to Linaro Forge, you want to talk about Linaro Connect that's coming up this year? Do you want to talk about any other Linaro services or cool stuff going on, or a charity? I don't know. Is there any shameless plugs you got?
So Linaro Connect, absolutely. If you're really an ARM fan, that's a place to go. And I'll take the shameless plug one. So one thing I've taken on the last 5 or 6 years in terms of kind of a hobby job, so to speak, is I serve on the board of a nonprofit, North London Mill Preservation, Inc. And I've always been kind of a history buff, and I've always been kind of a mining buff. And I connected with this project where, with one of the largest mining sites in Colorado, probably one of the largest in the country, that was almost completely dilapidated and gone. We're in the process of restoring it. And we first phase was we restored the office of this 1860s mining site and turned it into a backcountry lodge. It's absolutely beautiful. I go to a lot of backcountry huts, and I'm biased, but it's like the most beautiful one I've been to. And it's not just about recreation, although there's a lot of recreation. It's an incredible historical restoration of a very interesting part of Colorado history. So if you're a history buff or mining type of buff, check out North London Mill Preservation, Inc. and check out our project. It's been a lot of fun for me. It's been, having kind of a hobby job level things in career, not just about the day job. It's something that it is a job, but it's something fun to do.
If you send us a link to that, we can make sure it gets included in the description of the episode for later, Beau.
Great, thank you.
Michael, any last things from you before we shut this one down?
Yeah, I want to give a shameless plug to our office hours next week. I'm going to be off on some holiday time for myself, but we will have Shola, who's covering for the office hours in Europe and African time zones. And then we've got Gabe and I think Robert, you too, covering for our North American office hours. So please come to our Discord, go to the office hours, support those guys who are filling in for me while I'm off. Thank you.
Awesome. Okay. Well, then, Beau, thank you so much for your time today. And we appreciate having you here talking about Linaro Forge, Linaro, HPC, Performance Engineering, lots of cool stuff, I think, that happened today. We do thank you for that. And if you ever want to come back, if anything happens around Linaro Forge and you get some updates or, some new stuff happening there, feel free to ping us and we'll get you back on the show. We'd love to have you again. Other than that, are you okay if I close out the episode?
All good. I appreciate it.
Excellent. All right.
We do not have an innovation coffee next week because we are on our new every other week schedule. But who do we have coming up after next week?
Yeah, so our next episode is actually going to be on optimizing Java on ARM. This is a sequel with Dmitry Chuyuko. I hope I said that wrong. Sorry, Dmitry. I'll talk to you in a couple weeks. But Dmitry Chuyuko, optimizing Java on ARM, the sequel. So it should be a lot of fun. And I think we'll, I guess, see what happens when we get there in a couple weeks. So y'all enjoy that one. Other than that, I think we'll get this one on the road. Thank you, everyone, for joining. Beau, once again, thank you to you. Michael, amazing co-host here. We appreciate having you as well. And we look forward to seeing you in a couple weeks. For those of you who enjoyed this episode, make sure you smash that like button. Of course, subscribe to the ARM Software Developer YouTube channel. Join us on Discord for office hours. And, of course, just hanging out with us and thousands of other developers around the world. And we look forward to seeing you in a couple weeks on Innovation Coffee with Dimitri Chuyako, talking about optimizing on ARM. Y'all have a wonderful rest of your week, and take care. Later, everyone.
Thanks, everyone.